Hello, everyone. Uh, Finished up Unit 2. I haven't graded the test. I hope everyone did pretty well. Um, Hopefully you were prepared. This next unit deals with linear functions, equations, and their algebra. So there's 7 sections. I hope to get through 1 and 2, not on the same video. I'm going to make 2 separate videos and have that ready for Thursday. So we're going to start with the direct variation with proportions or direct variation. They're synonymous. They have what's called a constant of variation. So if you have 2 variables, x and a y, have a direct proportional relationship for every ordered pair, then the constant of variation will be the same. So if you take your y over x, any fraction, and simplify it, you should get the same k term every single time. So when we look here at each of the following x, y are directly related. So if they tell you it's directly related, that means the constant of variation is the same. So you set them up as equivalent fractions because the y over x will have to equal y over x. So we are going to take your y over x, and that has to equal y over x. And then you cross multiply, and you have 5 times y equals 15 times 9. And then you divide both sides by 5, and you get y equals 27. So they're directly related because if I put this y in as 27, 15, so we're going back up here, 15 divided by 5 has a constant of variation of 3. 27 divided by 9 has a constant of variation of 3. So that's what it means with your, direct relationships, and they are proportional. The next one, let's see if I can erase this first. I don't know what's going on. There it is. Okay, let's get rid of that. And back to this. Okay. So y equals negative 6, x equals 4. And so the constant of variation again, so negative 6 over 4 equals y over negative 10. So you have 4y equals negative 6 times negative 10. Remember, the 2 positives, the 2 negatives give you a positive. Divide both sides by 4, and then y equals 15. That's a 5. Y equals 15. Okay? And then in the last one, you have 12 over 16 equals y over 24. And again, if you need to use your calculator, by all means, of course, use your calculator. So we have 16y equals 12 times 24. Divide both sides by 16, and your y is 18. And then you can always put them back into check. 12 over 16 equals 18 over 24. Cross multiply or get the constant of variation. In exercise 2, the distance a person travels varies directly with the time they have been traveling, if going at a constant speed. So like that's on the thruway. You're driving on the thruway and with cruise control. So if Phoenix traveled 78 miles in 1.5 hours while going at constant speed, how far will he travel in 2 hours at the same speed? So what we need to do is we need to find the k, the constant of variation, or the unit rate. So we have our 78 divided by 1.5. So 78 miles per 1.5 hours. So, and when you simplify that, if you do 78, and I have the calculator here, and again, just use your calculator, 78 divided by 1.5, enter, and there's your 52. Okay, so plug it in, see what you get. So what that means is they're going 52 miles per hour, and that's your unit rate. So how far are you going every 1 hour? If you're talking about a unit rate, it's how much it is for 1 unit, whatever it may be. So if I'm going 52 miles per hour, and this is formally what you should do, y over 2. So that's how to set it up. I mean, you might just say, oh, I just have to double it, which is true. So if you have 52 over 1 equals y over 2, y equals 104. Okay, so that's 104 miles in the 2 hours. Now here's something that's more applicable to you. I don't know if I'm in the way or you can see this. Jenna works a job where her pay varies directly the number of hours she has worked. One week she worked 35 hours and made $274.75. How many hours would she need to work in order to earn $337.55? Unit rate, how much is she getting paid per hour? So $274.75 for 35. And $274.75, oops, 0.75, I know I'm not pausing it today, divided by, what do we have, 35, you get to watch everything, 785, so she's making 785 an hour, okay, so then you're back here, so 785, so that's the constant of variation. So if she wants to make 337.55, you can just divide that by 785. So back to your calculator, and I have, what, 337.55 divided by, and I just do the answer, bring it down, and you get 43 hours. So she needs to work 43 hours. That's her work week. Okay, and to make her $337.55. Okay. Also looking at graphs. So two variables vary directly. When x is 6, y is 4. So x is 6, so 1, 2, 3, 4, 5, 6. Oh, we already have it right there. Okay. X is 6, y is 4. Now want to find it when x is 3. So key thing is, if I do x over y, you can still find, okay, the missing value. So it doesn't always have to be the y in the numerator. So sometimes it could be the x. So I did x over y. Just have to make sure that these are x's, these are y's. Okay, you can't mix it up. You can't put one x in the top and one y in the top. So you can cross multiply and solve if you want. Or if you see that, oh, 6 divided by 2 is 3, therefore 4 divided by 2 is 2. Okay? So that means my x is 3, 1, 2, 3, and my y is 2. So there's your other point. And then when x is negative 6, so I have what? I have 6 over 4 equals negative 6 over y. And dividing by a negative 1, dividing by a negative 1, y equals negative 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So right about there. Okay. Does it say plot each point? So they're plotted. You can connect them if you'd like. Okay, so there they are connected. What is the constant of variation in this problem? So the constant of variation in this problem. Now, when you're finding the constant of variation, you want to say y over x. Okay, when you're setting it up to solve for missing values, it's okay to shift them around. But when you're looking for the exact constant of variation, y over x. So I go to the original, which is 4 over 6, and I'm going to simplify that down to 2/3. Write an equation, a line you plotted in part A. Okay, so the line I plotted in part A, since right here, this goes through the origin, that's the y-intercept. Now, what this constant of variation is, it is actually the slope up to and over 3. So we have y equals positive 2/3 x, and it's plus 0. So you just leave it as y equals 2/3 x. All right. Direct relations often exist between two variables that two values are 0 simultaneously. Miles driven by a car, D, varies directly as the number of gallons, G, of gasoline used. Abigail is able to drive 336 miles on 8 gallons of gas. Calculate the constant of variation. So what we want, again, constant of variation in your case, so sometimes y, the x, which is which. We want to find, again, the unit rate. So we want to know how many miles can she go per gallon. So we have 336 miles over the number of gallons. So 336 divided by 8 is 42. and that's 42 miles per gallon. Darn fly again. Give a linear equation that represents the relationship between D and G. Express your answers. So D is going to be miles driven. Okay, so D is going to equal 40. Oh, is it 42? Oh, right here. Yeah, 42. 42 miles per gallon. So the distance equals 42 times the number of gallons you use. So there's a linear equation. So D is the distance, which equals 42 miles times the total number of gallons. In C, how far can Abigail drive on 6 gallons of gas? G equals 6, 42 times 6, and you get 252 miles. How many gallons of gas will Abigail need in order to drive 483 miles? This time it is driving 483, so it's 483 equals 42 G for gallons. Divide by 42, and you get 11.5 equals G. So she's going to need 11.5 gallons of gas. Okay, that's it for this one. A little longer, but not a crazy concept. All right, well, I guess I will see you in class.